Today we're going to look at the graphs of the sine and the cosine functions. So first of all, let's just remember how these functions are defined. One way to define them is using the unit circle. So the unit circle, that's just a circle that is centered about the origin, and its radius is equal to 1 unit. That's why we call it the unit circle. And because the radius is equal to 1, well, that allows us to label some of the points on this circle. For example, this point over here is 1, 0. This point at the top of the circle is 0, 1, and so on. And to define sine and cosine, well, we consider an angle. Let's call our angle here theta. And so this angle is in standard position, meaning its initial side is the positive x-axis. And that has a measure of 0, either 0 degrees or 0 radians. We're going to be working in radians, so I'm just going to leave it as 0 without the degree symbol. That implies 0 radians. And the terminal side of our angle, well, it intersects the unit circle at some point. Let's call that point x, y. And well, the definition of sine of theta, so sine is this function that takes in this angle theta as its input, and the output is just the y-coordinate of that point on the unit circle. Similarly, cosine of theta is the x-coordinate of that point where the angle intersects the unit circle. And what we're going to do today is we're going to graph these two functions. So let's start by graphing how about sine of theta. So we are going to graph f of theta is equal to sine of theta. Right, so let's go ahead and set up our axes. Our horizontal axis, which is usually our x-axis, well, in this case, notice our input is theta. So what we really have is a theta axis. And then our vertical axis, those are going to be our function values, f of theta. And now let's go ahead and plot some points. So let's start out at an angle of 0. So we're starting over here at this point. And our angle is 0, and sine of 0, well, is the y-coordinate. So our function value is also 0. So that means the first point on my graph is going to be 0, 0. And now what we're going to do is we're going to travel around the unit circle in the counterclockwise direction, because that's the positive direction. And let's notice, as we travel around the unit circle in this direction, what's happening to the y values? Well, they're growing. They're getting larger and larger, all the way until we get up to the top of the circle, where we reach the highest y value of 1. So that's going to be like our maximum function value there. And where does this occur? What angle is this? Well, this 90-degree angle in radians, that's pi over 2. So if I come over to my graph, my theta value here is pi over 2. And what's the function value? Oh, it's that y value of 1. So here we go. We have this point on the graph as well. I could go ahead and label it. This is pi over 2, 1. Okay. Now if we keep moving around the unit circle in the counterclockwise direction, now what's happening to these points on our circle, what's happening to the y values, they're getting smaller and smaller, all the way until we reach the x-axis. And so on the x-axis, let's see, this angle over here is pi. And what is this point? This is the point -1, 0. And so our function value, again, it's just that y-coordinate, which is again 0. So at an angle of pi, my function value is again 0. All right, let's keep moving around the unit circle. So now we're coming down, we're in the third quadrant. So now notice our y values, our y coordinates are actually negative. And they keep going down until we reach the bottom of our unit circle. And well, what is this angle here? This is the angle 3 pi over 2. Okay. And what is this point on the unit circle? Oh, this is the point, what is that? 0, -1. So now my function value is -1. That's the y-coordinate. So on my graph here, my angle is 3 pi over 2, and my function value is -1. So we have this point right here. I could label it. This is the point 3 pi over 2, comma negative 1. And now if we finish our trip around the unit circle, now we're in the fourth quadrant, and notice our y values are still negative, but they're getting larger. They're going to come back up to a y value of 0. So, and what is our angle here? We started at 0, we went all the way around the unit circle. We'll end up at an angle of 2 pi. So these two angles are coterminal. They have the same location. So my angle is 2 pi, and my function value is 0. And if we connect the dots, we get this sort of shape. We call this a sine wave. Now, of course, we could continue. We could go around the unit circle again, right? And if we did that, well, basically we would be going from an angle of 2 pi all the way to 4 pi. And if we did that, notice the y values are just going to repeat. The y coordinates stay the same. And so this sine wave we came up with, basically we're just going to repeat this. And so we're going to go on an interval from 2 pi to 4 pi. That'll be another trip around the unit circle. And we should get the same exact pattern. Notice our pattern here. What did the points do? And notice we have these like 5 points that we came up with. They're going to act as our guidelines for graphing these kind of functions. And for the sine wave, notice it started at 0, went up to 1, back down to 0, down to negative 1, back up to 0. So we're going to get those same exact points, right? I can kind of break up this interval here. Notice what I'm doing is I'm breaking up my interval into these 4 equal segments. And the pattern is we start at 0, we go up to 1, back down to 0, down to negative 1, back to 0. And well, let's actually label the theta values. What are the angles here? Well, I know halfway between 2 pi and 4 pi, right in the middle, that's 3 pi. And where this maximum occurs, well, that occurs halfway between 2 pi and 3 pi. So what's halfway between 2 pi and 3 pi? Well, we'll just take their average. So 2 pi plus 3 pi is 5 pi, and then divided by 2. Similarly, what's halfway between 3 pi and 4 pi? Well, we take their average, and we get 7 pi over 2. That's where that minimum value occurs. And so if we kind of connect these dots, we get a whole nother cycle of our sine wave. And of course, we could continue again. If we went another trip around the unit circle, that would be on an interval from 4 pi all the way to 6 pi, and so on. We can go to the right forever. We could also go to the left, in which case we'd get negative theta values, and that would be the same as just going around our unit circle in the clockwise direction. And if we did that, we'd still get the same exact y coordinates, and this pattern would again just repeat itself. Right. Now, because this pattern repeats itself, this function repeats itself, we call these kinds of functions periodic functions. And if we were to look at one full cycle, so one trip around the unit circle, we see that that occurs on this interval from 0 to 2 pi. And the length of this interval is, well, it's 2 pi. And so we would say that the period of our function here is 2 pi. So by definition, the period of a function is just the length of one full cycle. Now, one more thing, just like any function that we study, we like to find the domain and the range. So let's do that. So what is our domain? So what kind of theta values do we have? Well, since we can go to the right forever and we can also go to the left forever, our domain is going to be all real numbers, or if you like, negative infinity to infinity. Right? In interval notation, that's how we would write it. If you like the fancy notation for all real numbers, that's this guy here. So either one of those. They mean the same thing. Our range, so what's happening to our function values, notice the lowest y value we have is negative 1. We don't have anything below that. And the highest y value we have is positive 1. We don't have anything above that. And of course, we get all those y values in between as well. Okay, so our range here is negative 1 to positive 1. And since we actually have those particular y values on our graph, we have points that attain those y values, we'll make sure and include those y values with brackets. All right, last thing, let's take a look at the cosine function. So now we're going to graph f of theta is equal to cosine of theta. And let's draw our axes. Again, we have a theta axis, and we have our function values. And let's see, up here for the sine wave, we did 2 complete cycles. For this one, let's just do 1 complete cycle, because we know it's just going to repeat itself. And our full cycle is still going to occur on 1 trip around the unit circle, so from 0 to 2 pi. And what we need to do is we want to break up this interval into 4 equal segments, just like we did for the sine wave. So right in the middle, so we start at 0, we end at 2 pi. Right in the middle is pi. Halfway between 0 and pi is pi over 2. And halfway between pi and 2 pi, well, that's just the average of 1 pi and 2 pi. So that's going to occur at 3 pi over 2. Let me make this a little better. All right. So now let's start plotting some points. All right, so now we have to look to see what is the cosine function doing. So starting at an angle of 0, well, the cosine function, remember now we're looking at the x-coordinates. So our first point is going to have an x-coordinate, or a function value rather, of 1. So at an angle of 0, my function value is 1. So there's the first point on my graph. At an angle of pi over 2, my function value is 0. At an angle of pi, my function value is -1. At an angle of 3 pi over 2, my function value is 0. And at an angle of 2 pi, my function value is again 1. And so now if we connect these points, we get this sort of picture, right? Which of course is just going to repeat itself to the right and to the left. And notice this cosine function looks a lot like the sine function. So it's another periodic function. And the length of 1 full cycle is the same. It's also 2 pi. So our period is again 2 pi. And what about our domain and range? Well, again, our angles can go to the left and right forever, so all real numbers. And our range, we get basically the same kind of y values, so -1 to +1. And there we go. These are the basic graphs of sine and cosine.